Now let's do the same thing with higher roots, but deal with some variables underneath theirs. So the first one, I have the cubed root of z to the 9th. I could look at this as z cubed. And the reason why I'm doing that is to really highlight that this root and that third root will end up getting rid of each other. And really what's left over is z cubed. Again, note that this really meshes with some of our earlier work, where I could write this as z to the 9 over 3, and I'll still get z cubed. So all of our rules are staying nice and consistent with one another. Okay, the cubed root of 8x to the 6th. So I'm looking at the cubed root of 8 and the cubed root of x to the 6th. Well, that would reduce to 2. And then this would be like x squared cubed. So 2 times x squared, that'd be the final reduced expression. All right, continuing on. I have the cubed root of 54t to the 5th. Now this one I'll try and break down as much as possible, but remember, if we have things that are still not cubic, we'll have to leave them underneath the root. So let's see. What cubic numbers can I find in 54? Well, that'd be the same as, say, 27 times 2. And then what cubic numbers could I grab from t to the 5th? Well, that's like t cubed and t squared. Notice here I'm really thinking of my product rule for exponents, how I'd have to add those exponents together in order to get 5. I've split them up in just this way so that I would have one of them that is cubed. Alright, so then we could take the cube of everything in here. So the cube of 27, the cube of 2, the cube of t cubed, and the cube of t squared. So some of these will simplify, some of them won't. The cubed root of 27, that'd be a 3. But the cubed root of 2 has to stay. Cubed root of t cubed is t. But then the cubed root of t squared, well, that one has to stay. So gathering up what was able to be taken out, I'd have a 3t times the cubed root of 2t squared. So simplify and bring out as much as you can. But if you can't, go ahead and leave them underneath the root. Alright, and one more. I'll first split up the root over the top and on the bottom. So a to the 15th over the cubed root of 64. Now on the top of this, that's like a to the 5th, all cubed underneath the cubed root. And then for the 64 on the bottom, that's something I could just take the cubed root of. Alright, so this would simplify into a to the 5th, and the cubed root of 64, 4. And then that one simplified. So again, be more familiar with your rules for these radicals, especially when it gets to being able to split things up and simplify over each of the individual components. Thank you for watching Educator.com.